Hey. Okay. We on? We're streaming. Hey, Mystery Flower, how are you? Hey, DD Band, how are you? Okay. Um, you know the drill. Mic check, audio check. Mic check, audio check. Video check. Okay, all good. The Twitch app is a little wonky right now. Oh, nope. We are not done. There you go. We gotta have light. You gotta have light. All right. Got a minute left. Hopefully everyone is. Yeah. All right. Mic check, audio check, video check. Okay, we're ready to go. We got a minute left. How is everyone? Hey, Golden Energy. How are you? Hey, Golden Energy. Yeah. Hey, Kyra. How are you? Kyra. Torvi. 7. Hey. All right. It's 4:30 right now. It's 4:30, and this is episode 4. Yeah, we're already on the what? We're already on 4 weeks, if you can believe it. We're a month into the course already. Yeah. So, hello everyone. I'm Ming Chow, Associate Teaching Professor at Tufts University. Yes, this is the Introduction to Security course, episode 4. Yes, the legendary episode. Hey, Sam, how are you? Sam, Dust. So, one public service announcement. October is National Cybersecurity Awareness Month. I repeat, October is National Cybersecurity Awareness Month. It's also Breast Cancer Awareness Month as well, too. And so, there's generally a reason why I love teaching this course in the fall, because it coincides with National Cybersecurity Awareness Month. So there's going to be a lot of promotions, a lot of awareness, a lot of activities, and also now a lot of return of in-person activities for the month of October. It's also a month of hijinks as well too. Hijinks, perhaps things that the not so good kind of hijinks. And today is going to be, we're going to talk about hijinks as well. Hijinks in the matter of as a distributed denial of service. In fact, today's entire topic, I know that this stream today is called distributed denial of service, DDoS, Scapy, and we're going to have John Hammond talk. But really, the whole gist of today is how you bring down the internet. Yeah, I mean, you can just rename today as how do you bring down the internet. And we're going to show you the tools and techniques. Hey, Crispy Nuggets, how are you? So, the first and foremost, what is distributed denial of service attack? Well, the whole idea of denial of service means, well, render a service or a system inaccessible to people who need it. So here's a good guide from, hey Bean Boy. Hey Bean Boy. A distributed denial of service attack is a malicious attempt to disrupt the normal traffic of a targeted server, service, or network by overwhelming the target and the surrounding infrastructure. Okay, so these days, distributed denial of service it's not just common, it's extremely common. There's a DDoS attack going every minute, if not every second, right now. Hey, Rose Phoenix. You're on. Good. Cool. And distributed denial of service attack, why is it such a big problem now? Causes havoc, that's number one. But at the same time, we now live in a world with so many computers and computing devices connected to the internet. And a lot of those devices are just, well, I would like to just say crap. They either have a weak password or they're just riddled with vulnerabilities. Um, so that's what DDoS is. And it's just, well, just flooding a target service network by overwhelming it, making it inaccessible. And these days, it's a very common thing. It happens every second, thanks to just way too many devices, namely cracked and vulnerable devices connected to the network. So yeah, I mean, using distributed denial of service attack by using all these different types of computing devices, you can bring down services and internet. You know, in fact, it doesn't. In terms of the cost, it's now gone to a point where you can do this on just like tens or $20, $30. That's all you need. It doesn't take much these days. If this was 20 years ago, totally different story. So, how do you do a distributed denial of service attack? Like, what can you do? How do you conduct one? We're going to demonstrate. So, I'm going to start off by doing a quick review conceptually of amplification attacks, and how you do this programmatically using, using Python. Yes, you can write a computer program. You can write a program that can do this using Scapy. I wouldn't try it at home. I mean, it's considered illegal, but the tool that you use, Python and Scapy, are perfectly legal to do that. And I'm gonna have John Hammond explain that later today. But just a quick review of amplification distributed denial of service attacks. And the reason why I gotta bring this up is because there is a pattern. And this is one of my absolute favorite articles that I have students read and review. And this is how a very common way to do, and also a very sinister way to do distributed denial of service attacks. And this article goes into how you can send just so much data and bring down a target with, a good number of computers. Okay, so let's talk about the original amplification attack. So the whole idea of an amplification attack is a way for an attacker to magnify the amount of bandwidth that they can target at a potential victim. Your one computer is kind of hard to send out like so much traffic, but you need to have a small army of computers, ideally hacked ones from somewhere else on the internet. So you rely on them to conduct the attack. Okay. So the original amplification attack is better known as the Smurf attack. Yes, it's named after Smurf as the cartoon. But the key about the Smurf attack is it involves sending ping requests to the network's broadcast address of a router configured to relay all the devices behind the router. So what it is, to make a long story short, is how Smurf attack works is the attacker will send a ping request, ping packets, to a whole number of devices. But the caveat is the ping requests all have spoofed source IP addresses. Spoofed or forged source IP addresses to be the address of the intended victim or the target. So in this case, the attacker, don't worry about what the attacker's IP address is, but the victim's IP address we know is 9.9.9.9. So what the attacker will do, it will send a ping packet or ping request to each one of these computing devices, a ping request or a ping packet to each one of these devices, but will say that the source IP address is from 9.9.9.9. And when each and every one of these devices receive a ping, they're going to say, oh, okay, I received a ICMP or a ping echo. I'm just going to send a reply to who sent it to me, which looks like it came from 9.9.9.9. And so each and every one of these devices will send a ICMP or ping reply to 9.9.9.9, the target or the victim. And the target or the victim will be like, what the hell just happened? Okay, like what the hell just happened? This is a thing of the past now. Just for your interest and for a little bit of a history lesson, this Smurf attack was used to take down White House. Not whitehouse.com, the adult entertainment website, but whitehouse.gov. Oh yeah, back in the heydays. Yep. So the Smurf attack was used to bring down the White House website. Long time ago. Probably around the time you were all born. Yeah. But ping is a thing. The Smurf attack is a really large thing, the thing of the past now, because a lot of routers and computer systems you can just block ping. So, okay, is there something else that we can use instead of ping to conduct a distributed denial of service attack? And the answer is yes. There's a caveat. So, okay, we need to have two criteria. One is that the query can be set with a spoof source address. So something like ping or ICMP or UDP are great because ICMP level 3 or UDP on layer 4 of the OSI model, they do not require a handshake. So no sync, no sync ACK, no ACK. So if you're actually doing ping or UDP, there's no handshaking involved. That means you can also forge or spoof a IP address. You can set it to whatever you want. And there's no verification of the source IP address. Okay? And also the response to the query is significantly larger than the query itself. So in fact, DNS. So DNS, if you don't know, is domain name systems. Domain name systems, think of it this way, again, just a review, it's the yellow pages of the internet. Translate domain name to IP address or IP addresses. And DNS is, like, there's a lot of open DNS servers out there. But the other thing, and also DNS uses UDP. Meaning, like ping queries used in the Smurf attack, they fire and forget. And as a result, and this is the line, as a result, the source attribute can be spoofed and the receiver has no way of determining its veracity before responding. So as you can see now, both DNS amplification and Smurf attack, they have one very important thing in common. You can spoof or forge the source IP address in the packet. So you may be asking yourself, like, what the hell? I can do that? We can do that? I can create a network packet with a source IP address of anything that I want? The answer to your question is yes. So how do you do that? Well, there's a couple ways. One way is you can do it by hand, using bytes. That's a pain in the ass to do. You don't want to do that. You can do one by hand. So, you don't want to go that low level. But you want to do something a little more high level, like something programmatically or a tool that does that. One very, very popular tool that is used in the cybersecurity community and also professionally, it's called Scapy. I call it Scapy. Other people can call it Scapy. It doesn't matter. So what is Scapy? Go to scapy.net. I have a lot of friends that actually named their pet Scapy. I call it Scapy. Scapy.net. Scapy is free and it's open source and it's based on Python. Okay? So the whole point of Scapy, and oh wow, holy shit, Scapy actually has a brand new website. They totally redesigned their website. Scapy's been around for almost 20 years. Yeah. It's cross-platform. It's cross-platform. You do need Python though. You can use but then again, Python is so platform independent anyway. Works natively on all the platforms. That's a great thing. And so what Scapy is, it's you can use it's what they call it a packet manipulator. Okay, so you can use Scapy to read and write network packets. You can also use Scapy to decode packets from a whole wide range of protocols. You can use Scapy to write your own security tools. You can write your own. You can write your own basically Wireshark or EtherCap using Scapy. You can also use Scapy to do things like arc poisoning. Yeah, you can do that. Um, you can use Scapy to build a network monitoring tool to see if someone's sending malware. Well, that's what you're doing for what the security class is doing for lab number 4. So the the number of options and things that you can do with Scapy is use your imagination. All you need is Python knowledge. All you need is learn how to use Python. Now this is interesting. One very important note is that Scapy can be used as both a command line tool, or you can just write a Python program that loads in Scapy. It's so cool. It's really, really cool. May even have a example here. But the important thing is the documentation is pretty extensive. So here is the documentation, the official documentation, or what I call redefined manual of all the functions and attributes in Scapy. Okay, so first and foremost, if you have, well, I'm on a Mac OS, so I better make sure that I show you how to get the setup correct. Now, if you have a Mac OS, okay, if you have Mac OS, well, actually, if you're on Windows as well too, the first step is you have to install Python. Here's the thing about Mac OS. For the longest time, Mac OS they install Python. Python is installed for you, but the problem is the development tools on Mac OS is always outdated. Always. What you want to do is to install the latest version of Python. You always want to do that. You always want to be using the latest version of any development tools on Mac OS, and the best way you do that is to install by way of Homebrew. I use Homebrew. So the first thing that you want to do before you get Bobby Tables 24. Yeah, unfortunately, Python 2 has been what you call deprecated now. It's still around, but it's deprecated. So moving forward now, like everything got to be in Python 3. Yeah, and yuck. All right. When did they deprecate Python 2? It was like in 2020. It wasn't that long ago. Well, install the latest version of Python. You can do brew install Python. And this will install the latest version of 3, whatever it is. So, okay, Python, the latest version is 3.11, actually 3.115. So the first thing that you want to do if you have Mac OS is to install the latest version of Python. Ideally, do it using Homebrew. Why Homebrew? It makes installation of any software tool that you need really, really simple. So if you're on Windows, Python for Windows. Python for Windows. And yeah, here you go. It's the latest version at 3.11.5. So you would go to python.org/download/Windows, download the version of Python for Windows. Okay. Then the next step is going to be for both Python, for both Mac OS and for Windows. Okay. Once you have Python installed, you need to install Scapy. Now to install Scapy, the best way, the easiest way, is to use the Python package manager pip, PIP. So you would do pip3, or if you're on Windows, it's probably pip or pip3 on Windows. It's either one would work. On Mac OS, we try to get everything with the formal numbers, or like pip3 install Scapy. That's it. And once that happens, I already installed it. Well, I already have Scapy installed. Step one is to get a Mac install Linux. Yeah, I mean, it's a pain in the ass to do. It's easier said than done, you know. Let's not get into a flame war on operating system. But yeah, the Windows subset for a subsystem for Windows, it works great for Windows. It is. It's not perfect. Nothing ever is. But it's definitely good enough. Hey, there were even days I actually almost wanted to switch over to Windows. Well, but that's a longer story for another day. Okay, so now I'm going to show you a couple of examples. Now you have Python installed, you have Scapy installed by way of pip. By the way, I think for Mac you can do, yeah, they should be the same. So use either pip or pip3. Okay, I'm going to clear the screen now. Once we've installed Python and Scapy, well, let's do a couple of examples. The first example is inline. Scapy by way of the command line. And the way you do that is, right, Scapy. You're welcome. We are on Scapy. Here we are. And once you have Scapy, this is what you call interactive mode or command line mode. This is generally if you want to test stuff out. Okay, this is not the place where you're going to write your full Python program. Okay, this is not where you're going to write your full Python program, but this is where you can do like interactive examples. Okay, and the interactive example that I want to create is, well, how do you create a packet with a spoofed source IP address? Namely, a ping packet. And the way I'm going to do that, I'm going to show you that is, well, I'm going to open up Wireshark. I need the browser back later. Can you all see? Is the terminal screen clear for each and every one of you? Is it good? Is it? I'm also going to fire Wireshark. Why Wireshark? And the reason is, okay, and the reason why I'm going to load up Wireshark is so you can see what's really happening under the hood. I'm going to create a packet. I'm going to create a ping packet. I'm going to create a ping packet with a spoof source IP address. I'm going to send it. And you're going to see the results on Wireshark. Oh yes. So right now, I am in Wireshark. I'm going to do a capture options. And I'm going to start monitoring my internet network on, well, I'm using wired, not Wi-Fi. So my interface I'm going to sniff on is going to be EN4, not EN0. I'm not using Wi-Fi. I have it enabled, but I don't use Wi-Fi. For streaming, I always use wired networking. So I'm in EN4. All right, so this is, yeah, so RTMP is the entire stream to Twitch. I don't want that. I just want to first see only ICMP packets. So if I just want to see ping packets, or ICMP, who the fuck is pinging me? Pardon my French. Why is there a ping going on? What the hell? And why are there beers or bottles on the wall? Who's sending me stuff? Where is this coming from? Where is it bottles of beer on the wall? No, I mean, this is so weird. Who sent me beers or bottle on the wall? Hold on, what happened if I try to quit out of this? Don't worry. Huh, this is the strangest thing. Who's sending me beers a bottle on the wall? Who's sending me 46 bottles of beer on the wall? No, I mean, these are two computers on my network. Anyway, this is strange. Alright. It's just funny, I don't know who actually threw 35 beers a ball on the wall. Who would send me this stuff? Okay, anyway. Alright, I don't know, folks, so I'm just going to type Scapy. Alright, let's go back. Yeah, when you're gonna hit 0, your computer dies. Yeah, haha. Who's sending me beers of bottle on the wall? These are 2 computers on my network. There's no one else on my network right now. There shouldn't be. Well, someone did break in. I don't know. 22, 21 bottles of beer on the wall? Why? All right. Anyway, I really don't know what's up with this. So here's how you create a packet. Well, like if you don't know Python, it's okay. But you know what variables are. I'm going to create a variable called packet. So I'm going to do packet equals hello. This is just a simple print statement. All right, this is how Python works. Set a key equals a variable equals, you know this stuff. Okay, so I'm going to do now packet equals the IP header. Now, generally, you need to specify the source and destination for any packet. So watch what happens. I'm going to create an IP packet that I'm going to send to the server at, I know I have a server of 192.168.1.8. Okay. Oh, that's not enough. DST. So what this is going to do is going to create a packet with the IP field, well, the source and destination. But I'm going to specify you need to specify the destination. That goes without saying. So destination equals 192.168.1.8. But this is a ping packet, so I'm just going to do a layer, a slash, ICMP. So what I'm going to create right now, this is a ping packet. It has an IP header, but the destination goes to 192.168.1.8. Good question. Do you need to import the IP module from some library first? And the answer is no, you do not. That's a great question. You don't. It's already built in to Scapy. Great question. Now watch what happens. That's a great question. No, you don't need to import the IP module. It's already built in. So I created a packet called IP. A packet that is a ping packet that goes to 192.168.1.8. Now to send the packet, you do the send function, you send the packet, and hopefully you will see it. You will see a 192.168.1.8 in Wireshark. Here we go. Boom, you see it. 192.1, okay, so my IP address right now locally is 192.168.1.244. So it sends a ICMP echo request to 192.168.1.8. And of course, I received a reply 192.168.1.8 to my computer. Great. And the IP class has a division operation defined on it, lol. Yeah. So the reason is, think of it this way. Here is, Bobby, this is a good question because the way you should think about this is the slash mark, it really means layering. That's the way I look at it. So a packet, so hold on. If I do a print statement on packet, watch what happens. So you can see it's an IP packet, ICMP, 192.168.1.244 to 192.168.1.8, echo request 0. That is actually how the stringified version of the Python stringified version of the packet really looks like. We'll do an example of this programmatically. Now, I'll do this example again, but this time I'm going to hit record. I'm going to actually capture option. Capture on EN4 again. Who the fuck is sending me beers a bottle on the wall? Why is it sending me beers a bottle on the wall? This is the most weirdest thing I've ever seen. I gotta look into this after this. Like, who's doing that? Anyway. Yeah. So I'm gonna do another example now, but this time I'm actually, oh god. Print the packet. Okay, so I'm gonna start this over because one of the things about the command line can be a little bit wonky at times. So now I'm gonna create I'm going to create a ping packet again, but this time I'm going to create a ping packet that has a spoof source IP address. So IP header src equals 1.1.1.1, which is the Cloudflare DNS IP address. Destination equals 192.168.1.8 ICMP. So to forge the IP address, the source IP address, or to spoof the source IP address of a packet, all you just need to set is the src. That's all you need to do. So this is going to create a ping packet with the source being 192.168.1. The source being 1.1.1.1 and the destination being 192.168.1.8. Now watch what happens when I do. Well, I'll just print out the packet just to let you know. There you go. You can see the source IP address is 1.1.1.1, not 192.168.1.244, my IP address on this Mac. Now I'm going to send it out. Watch what happens when I send it out, though. I'm going to hit the enter key. Bing! There it is. What's interesting is, you can see in Wireshark, it has, here it is. Source is 1.1.1.1. Packet from 1.1.1.1 got sent to 192.168.1.8. And you can also see something very interesting. It says, echo ping request, no response found. Interesting. So you may be wondering, wait a minute. Did 192.168.1.8 receive the ping packet? And did it actually send to 1.1.1.1? Let's do that out. What I'm gonna do now is I'm gonna open up another terminal. I don't think I need to show Wireshark anymore, because you can see that when I sent the ping packet with the spoof source IP address at 1.1.1.1, it got sent out. Here is the evidence. Here's the packet with 1.1.1.1 sent to 192.168.1.8. Of course it makes no sense. I'm not 192.168.1.8. The only thing that I can't see what happened on 192.168.1.8's end. Okay? So you may wonder, okay, what does the computer at 192.168.1.8 sees? Take a look. I'm going to do a continue without saving. I'll still leave this thing on, I guess. I don't know what this beer's a bottle on the wall thing is. This is very weird. I'm going to open up another tab. Or another window. You can see. So I'm going to SSH into 192.168.1.8 on my computer. Oh, damn. Okay, here we go. I've logged into 192.168.1.8. But now what I'm going to do is sudo, I'm going to use TCP dump. If you don't know what TCP dump is, basically capturing packet dump traffic on a network. Think of it as, it's basically very similar to T-Shark without the filtering feature. So I'm going to do an if config on this network. So the network, okay, so the interface is ETH0. Sudo if config -I ETH0. But I also just want to show ICMP. So what this is going to do is only going to show any ICMP packet. Oh. This is a filter? Oh, no, I'm an idiot. Sudo TCP dump ICMP. I'm a friggin' idiot. There you go. Now I'll do this again. So right now, this dirty work computer is 192.168.1.8. This time, I'm going to send that ping packet with the spoof source IP address at 1.1.1.1 again. Watch what happens when I hit the send. When I send the packet, notice what's going to happen on the command line on the terminal here. This computer here is 192.168.1.8. Hey, Broccoli Muffin, how are you? Boom. On my computer on Wireshark, the packet got sent. No packet and no packet from 1.1.1.1 got sent to 192.168.1.8. That got sent. Of course, there's no response because this computer here is not 192.168.1.8. I don't need this anymore. This window, this computer is 192.168.1.8. As you can see, it captured it got the packet. So it read the packet that there was a request from 1.1.1.1 sent to 192.168.1.8. The computer 192.168.1.8 just like, what the hell, I got a ping packet, so it just sends back a reply. You can see the request and reply. All here, thanks to everything sent on my end from 192.168.1.244. So my Mac, where this Scapy is running, is 192.168.1.244. Now this is how this is a really, really simple exercise, a demonstration I showed, well, how you spoof the IP address of the source IP address in a packet. Simple as that. Okay. Oh, there's another one? I don't know what this is. I don't need this anymore. There it is. 3 cap packets capped. I don't need this anymore. Okay. But generally, you probably don't want to use the command line interface of Scapy unless you're doing like simple demonstration or simple stuff like this. Okay. The more common way to use Scapy is to write a program. It's to write a program in Python. I don't need this anymore. Exit is just exit with a paren. So for this class, one of the fourth lab, the infamous fourth lab, is to write an incident alarm. And the whole purpose of the incident alarm is to detect on a network or in a PCAP file, either way, the following stuff. No scan, bin scan, Christmas tree scan, usernames and passwords sent in the clear by way of HTTP basic authentication, FTP and IMAP. Determine what the hell a NICTO scan is. Someone scanning for SMB, RDP, or VNC. Yeah. So this lab requires you to use Scapy, to write a program using Scapy that will detect all these different types of incidents. Okay? The good news is, for those of you who do not know Python, I have written starter code. Okay? Here is a working alarm. Okay? This is all free for the taking, and this is the starter code. It works. Alarm.py. Now I'm going to copy all this code. All you need to do is copy all that. Fire up your favorite editor. In this case, I use Visual Studio Code. Paste it in. Save it. And I'm going to save it to my desktop called alarm.py. There you go. Yeah, and only thing that you really need to do is to modify the function packet callback. This is all that you're going to do for the lab. Now, what the function packet callback does, it just for each okay, so it's a command line tool. Do not modify any of this code below. Okay? Do not do any modifications to the code. But for each and every packet, whether it's on a live network or whether it is you're reading a PCAP, each and every packet will go through this function, packet callback. Okay? So for each and every packet, it will go through packet callback. Now, I am now going to go to my desktop, and here's my alarm.py. There are a couple ways, there are two ways that I can run this. So if I do Python 3 alarm.py, this is no good. Well, actually by default, it's going to say sniffing on ETH0, which is the default interface. Right here, the default interface is always going to look for ETH0, but it's not. It's nothing. And we don't have an ETH0 on Mac OS. If you're sniffing, by default, it's also going to be sniffing the live network, not reading from a PCAP. You can do Python 3 alarm.py -h for help. Oh, here it is. Yeah, that works. The -h option is a help. This is a network sniffer that identifies basic vulnerabilities. Okay, so there's really two options, the -i and -r. Read in a PCAP or a network interface to sniff on. Either way, the code base for packet callback, it's the same. So I'm going to clear the screen now. And so if I were reading in, let's say, a live network, I can do what you have to do. If you're going to be using the alarm to sniff a live network, you got to use sudo. So sudo python 3 alarm.py -i, and my interface that I'm using to get them on a wired connection is EN4, not ETH0, EN4. If I hit the enter key, now it's going to start to monitor my network card. So I need to go to an HTTP site because the starter code actually will read the packet. So if the packet sub TCP in brackets, so think of the brackets as the different layers. So if the TCP layer of the packet has a destination port of 80, print out web traffic is detected. So if I open a web browser now, such as here, and I go to http:// has to be an HTTP site, not an HTTPS, HTTP, mchow01.github.io, and I hit the enter key. Oh, shoot. EN4 does not work. Hold on. Is it really EN4? Am I EN4 or EN0? Oh, this is working because it bounced it. Alright, never mind. No, it is EN4. I'm correct. Sniffing on EN4. The reason is I have to go to my settings in Firefox. Oh. Privacy and security. What's the, okay, don't enable, okay, that's weird. But when it's forced, why is it forcing to be HTTP? I said HTTP, not HTTPS. Yeah, it's forcing it to be HTTP. That's not good. But wait a minute, where's this web traffic detected coming from? Where's the HTTP traffic coming from? We don't know. Well, let's do a couple of things. Hang on. To cancel out, to close this out and hit Control-C out of it. And let's do some modification to this code. So if packet sub TCP.D port equals 80, that means HTTP web traffic is detected. We might as well also print out the destination IP address. So you can print out the destination IP address of a packet by packet sub well, the IP, because source and destination IP addresses, semicolon, are in the IP layer. But I'm also going to add if packet sub tcp.dport equals 443 print browsing the secure web, print packet sub IP.dst. Okay. Clear the screen. It's packet addiction. Oh, hold on, Malagon. Hold on. Go to reddit.com. Boom. Who's this IP address? Let's do another tab. Who is... Okay, this is Fastly. 151, but the 142.251.40.227. So Fastly has to be the content delivery network. So who is 142? Okay, so the 142.251.40.227, that is a Google IP address. Any other IP addresses in question here? Yeah, who's 151? Did we do that one? Oh, yeah, we did that one. So it looks like there's a mixture of Google Web and some Google server. Let's clear this screen out. Let's do this again. But go to github.com. All right. So I got a github.com. So who is 185, 199, 109, and 154? Bing! GitHub. Yep. So I can monitor like, yep, so it actually got the correct destination address. So 185.199.109.154 is indeed GitHub. So yeah, it definitely did get all the packets. Well, DHCP S packets for GitHub. So it's a packet of dictionary. So Malagon, that question. The short answer to your question is yes, it is. What are the fields? You ready? How about this? Print packet. So Malagon, let's help to answer your question. Is packet a dictionary? The answer is yes. But how big is it? Like, what's the structure of a packet? What field do you have access to? Let's print it out. Let's go to cups.edu. Yeah, so you have Ether, IP, TCP, all this information raw. Okay? But this doesn't help you that much because let's go to the dictionary. Let's go to the Scapy documentation. Let's go to usage. Okay, building packet. Okay, build stacking of layers. You can read PCAP files, Ethernet. I want to print out. There is a function I know. Here it is. Display a list of summaries for each packet. So you can do that. What happened if we do that? What happened if I do... Can I do print summary? Oh, the packet. I don't know if this is going to work. Damn. No, something's failing. Summary's not going to work. Okay, but what happened if we did summary of the packet? Hit the refresh. Summary's not working for me. What the hell? Yeah, I'm not getting that. That's not working. Is there a function that would actually help us actually dig deeper in a packet? That a send? I don't want that. Bytes. Oh, to show. Okay. Look. P.show. Interesting. So it gives you all the different layers. What happened if I did that? Print packet show. That should do it. Boom. Got it. So here we go. So Malagon. Nah. Malagon. Nah. Yeah, I think it is, but it doesn't matter now. So here's what I did. I do a packet.show, and it just and now it shows the breakdown of the packet. You can see, okay, here are the fields. Here's the dictionary fields that you can access. Ethernet, DST, SRC, and type. You can see the IP headers, version, time to live, the protocol, source, destination. TCP, source, destination, sequence, acknowledge, all that. You can see all the different fields. I don't know why you got censored. I don't know why you got canceled. Okay. Hold up for a second. Hold up. I want to do something else. I want to see a packet. I'm going to change this all up. Let's see what it's like if the destination port is 21. If packet sub TCP that destination port is 21, also known as FTP, then print the packet out. Now, so far, I'm only just showing you what it's like when you run the packet, when you run the alarm on a live network. But I have, in my home folder document, the PCAPs, I have set1.pcap. I can do, now when you're reading in a PCAP and you're not using a live network, you don't need sudo. So if I do alarm.py, not -i, but -r, to read in a PCAP, that documents PCAPs set1.pcap. Watch what happens. It should actually identify, because set1.pcap from your lab 2 was all using FTP, the file transfer protocol. And that's what port 21 is. So what happened if I run the alarm on set1.pcap? Quit. Let's do that again. I'm going to open up set1.pcap from lab number 2 using this alarm. This alarm should actually identify, should I just take out the, should read the packets or identify the packets that have port 21 in them. It is. Notice raw is the header. The load is the payload of the data. User Slim Shady. Pass is better than Penaldo. the plot thickens. Well, anyway, I think I've given enough of a really good, I hope I've given you a very good introduction to using Scapy, not only on command line, but also how to write a program in Python using Scapy. But I'm not the expert. I'm going to turn it over to someone who else is. And it's my pleasure to introduce you to John Hammond, the legendary John Hammond, who cybersecurity, he's not only, he's an amazing teacher, but he does this for a living with certain government agencies. And this was his presentation to us at DEF CON 20 in 2020 when it was virtual. So I want to show you now. I'm going to transition over. John.
Alrighty, hello everyone. Welcome. Thank you for tuning in. I appreciate you being here. This is a talk and presentation titled Take Down the Internet with Scapy. I'm presenting this as part of DEF CON 28 or DEF CON Safe Mode, and I'm here at the Packet Hacking Village. So let's dive into the presentation, but before we do, I've got to say this. I've said it before, I'm about to say it now, and I'm certainly going to say it again many, many times throughout the presentation. Thank you. Thank you for being here. Honestly, seriously. Them, I'm not speaking for them, etc. This is stuff that I wanted to bring to you, me personally. Other disclaimer, don't or do try this at home, right? Anything that we talk about, anything that I showcase here, obviously it's a talk titled Take Down the Internet. Don't actually do that, or maybe do it at maybe your own small scale lab environment, etc. You can tinker with it and explore with it, but don't actually take down the internet, right? Cool. Next, your mileage may vary. I bring this up with everything that I kind of try and showcase. Look, I'm talking about it and I'm showing it to you. Maybe you'll have different results. Maybe something will work differently or strangely in the way that you do it if you do this sort of thing. I can't promise, and I don't mean to make this any written in stone gospel or anything. The stuff that comes out of this talk, it might be different for you, and your mileage may vary. Okay, last bit. We're the good guys here, right? We talk about security. We talk about cybersecurity. We break things for the sake of making them better. We hack for good. And I want you to do the same. The stuff that we're going to talk about and showcase in this presentation, maybe it's a little bit on the different side of the fence. I want to reiterate to you and kind of enforce it. Hey, hack for good. Okay. Obligatory introduction, right? Who is this guy talking at you? Hello, my name is John Hammond. I'll try and run through this quickly because I know no one cares, not even me. I used to just do some stuff with the Department of Defense Cyber Crime Center and their Cyber Training Academy, and I also work with the Defense Threat Reduction Agency as a kind of a red team cyber operator. Right now, I'm working as a senior security researcher over at Huntress Labs. Again, not speaking for them. These are my words, not theirs. And in my free time, I like to play a little bit of Capture the Flag. I like to develop and create and host Capture the Flag events or competitions or exercises and training sets to try and make people better, to try and improve everyone's cybersecurity skill. On that same coin, I do produce some cheesy YouTube videos. I publish and showcase some Capture the Flag write-ups or programming tutorials, video guides, stuff like that. But that's all nerdy stuff that you don't really have to care about. Let's talk about what we're going to talk about. Kind of meta, right? So here's the agenda, the roadmap, the outline for our discussion. First, we'll lay the groundwork. We'll put down a little bit of a background, really set the scene for what we're going to be discussing. I'm going to be talking a little bit about Python, right? Python's kind of my weapon of choice, but we needed to make a distinction between Python 2 versus Python 3 and what we'll kind of be using as our vessel throughout this talk. Then I'm going to introduce Scapy, one really, really cool Python module or library that you can pull into your Python source code, use with your projects, your other scripts, whatever you're working on to do really, really cool low-level stuff with network packets, with the stuff that you would find in PCAPs, if you were taking a look at it in Wireshark or TCP dump, etc. We're going to do that with Scapy inside of Python. So we'll talk about how to install it, some documentation, syntax, and use cases, etc. Then we'll get into the real meat of the conversation. We'll talk about different attacks that we could perform, and we'll kind of zoom in or zoom out as appropriate on some of these different things: the ping of death, the SYN flood, DNS attacks, BGP, etc. I do want to showcase a couple of IRL or in real life cases, right? Stuff that we've really seen out in the real world that is real. All about the stuff that we're kind of laying the foundation with here, Python, Scapy, and these network attacks when we're trying to take down the internet. We'll also discuss some of the defense and mitigation, some things that we could do, some things that we might consider when we take note of all these network attacks we're going to be looking at. Finally, I'll showcase some of the resources and references that I use to put together this conversation, this talk for you, and we'll have the boilerplate template slides, how you can contact me, and of course, I will thank you again and again. I'm really, really appreciative that you're here. All right, let's get into it. To get things rolling, let's lay the foundation. We're going to be talking about packets, right? We're here in the packet hacking village. We're talking about network-oriented stuff. So naturally, we're going to be talking about packets using Scapy, using Python, and we'll dive into that more. But I want to say the title of this talk, right? The whole theme, take down the internet, that's going to be doing a lot of kind of jerk stuff. It's about obnoxious, annoying, adversarial, and disruptive attacks. So nothing like elite, super cool, 0 days, crazy like Ninja Warrior, cyber hacker stuff, but really just being mean and breaking stuff. We're trying to recklessly break stuff. I want to showcase some of this to you because really I want to show you just how easy it is and how Python, just the same scripting language that's about on every Unix system, can do this stuff. And how you could do it if you really wanted to, but you shouldn't. You don't have to, right? Take down the internet. Obnoxious, annoying, adversarial, and disruptive attacks. That's the background. All right, now let's talk a little bit about Python. I'm going to be using Python as the vessel for this talk, right? We want to make this a little bit of a technical talk and showcase some code, showcase some real stuff, rather than just pointing at numbers on a graph. So I want to lay the foundation again with Python. Python is a wonderful hacker's language. Yes, it's a scripting language. It's not compiled. It's read through an interpreter, but it is easy to read and easy to write. That means that it's super duper friendly. It's really easy to knock out quick testing scripts or to rapidly prototype some ideas. It's just handy and useful and has a lot of support between all the different libraries and modules and packages that you could pull into your code and do some really, really neat stuff. So there's some conversations, right? Because now we are in a new era. We are in 2020 and Python 2, the older version of Python, is dead. It's not on the table anymore. Python 2 reached end of life at the start of this year, and now Python 3 is the officially supported version. Please don't hate me for screaming about that. I just want to make sure, hey, everyone knows we're using Python 3 and you should be too. And of course, Python is part of Linux. It is typically shipped and natively kind of built into a lot of common Linux distributions. And honestly, you should be using Linux. I don't know why you wouldn't be. And because it is part of Linux, it's really, really easy to access it just from the command line. You can simply type in Python, and then you're inside of an interactive shell or interpreter to work with the Python language. I'm kind of being explicit here. I'm using Python 3 with that suffix 3 at the end. You probably will just be able to invoke it as regular Python, and maybe that would spin up Python 3 for you. But if it does, fire up Python 2. Hey, you should know better. Go fix that up and hop over to Python 3 now as the officially supported version. Python, while we could be working inside of the language within the interpreter or within that shell, oftentimes you'll likely want to create a script or file with a .py extension, maybe a shebang line, and you can invoke it and run it with Python just as an automated tool, not manually working through the interpreter or the interactive shell there. In a lot of our conversations, what we'll be discussing, I am assuming you're going to end up using this inside of a script with a .py extension, and you don't need that interactive interpreter. Okay, let's move on because you probably all already know about Python, and this is boring. So let's talk about Scapy. Scapy is incredible, fantastic, phenomenal. It is a module, it's a library, it's something you can just install, pull in to use with your Python code, and it gives you the ability to craft network packets. You can customize them, you can forge them, you can create them, you can whatever you want, your wildest dreams, whatever sort of network layers or protocols or things that you want to use, you can get that fine-tuned, like zoomed in microscopic customization of what that packet looks like. And that's super duper cool. It's easy to install. I'm showcasing some commands here. I'm assuming, okay, a Debian-based distribution, maybe Ubuntu, you'll do a little sudo apt update and you'll install pip if you're working with that little handy Python package manager. And let's use pip install Scapy. Now, you could run Scapy in one of two ways. Very, very similar to what we talked about in Python, right? Scapy could be interactive, and you could work inside of an interpreter with a manual, like typing in commands and getting that returned back to you, like interactive shell. Or you could work with it inside of a script and have Python just import Scapy as a whole module, and you can access all of the code, the functions, the variables, name. But being object-oriented means we can do some kind of nifty things with it. Maybe not all the time. I'm not trying to say OOP is the way, but it's nice to have that kind of built into the language when necessary. So you can see I'm working in like a little bit of a script here, right? I've got a shebang line set up. I'm going to work with Python 3 as my interpreter, and I'm going to use that from scapy.all. It's so awesome is that it can all be automated and you can write it and you have that fine-tuned control all within Python. You have the entire arsenal of the Python language and libraries, modules, other tools that you can use and pull into it. So that's super duper cool. Now let's get into the good stuff. Let's get into the really cool attacks that could potentially take down the internet, right? So we'll start small, we'll start with some simple things, and then we'll slowly kind of zoom in onto more complex stuff. But just to kind of whet your appetite, let's start with the ping of death. Interesting name, right? So the ping of death attack is a denial of service attack where the attacker will stop a machine by sending a large ping packet. So large, in fact, that the machine can't handle it. It'll choke. There's so much data in that packet that the machine doesn't know what to do with it, and it'll freeze up or just fall over or crash. We talked about ping packets in the previous example, or that script and source code that I showed you earlier, when we were looking at that ICMP protocol, or the Internet Control Message Protocol. So typically, ping packets are very small, but IPv4 ping packets can be much larger, up to the maximum allowable packet size of 65,535 bytes. Some systems might not be designed to actually handle packets larger than this maximum, and they might be vulnerable to packets at that size, and they're sensitive to it, they'll choke, and they'll fall over. When this large evil packet is sent from the attacker to the victim, the packet becomes fragmented into different segments, each of which will be smaller than the maximum size limit. When the target and victim actually attempts to put these pieces all back together, eventually that total size will exceed that maximum size limit, and maybe a buffer overflow occurs or something goes wrong and that machine can't handle it. It'll freeze, it'll choke, it'll crash. So we're using this example where the ICMP echo or that ping packet could be used for this attack, but really anything that sends an IP datagram that can hold more data or can have this attached information that extends beyond that maximum size could be used for this attack. That could be TCP or UDP or any IPX stuff. admittedly, the ping of death attack is kind of old and a little outdated, but I think it works as a really cool and simple, quick jumping off point or starting point for us to take a look at some of these evil, nefarious things that we could do with Python and Scapy. So with that said, let's take a look at the source code here. You can see I'm using the send function, which is part of Scapy. We say we've imported everything into our namespace. You could also send just one packet and receive the information back, or send packets inside of a loop. But for just one quick shot, firing the gun, we can use this send function here. We'll create a fragment, as kind of we discussed earlier. Okay, sending fragments that might be rebuilt and reassembled by the victim machine that could potentially cause it to crash and choke. And inside of that, we'll build this ICMP packet just as we've done before in that previous example. However, you can see there at the end, we use another divider or to add in another layer or some more information into this packet. And I just use a simple dummy string. I just use the letter X and I multiply it by this large number. So I have this data payload, this information that I've strapped to this ping packet so that I can send a ping of death that's just a little too big. And maybe that machine is biting off more than it can chew. It'll choke and it'll fall right over. I did mention, though, that this ping of death attack is less common today, right? More so now, you'll see other kinds of attacks that are still this denial of service attack, right? We're being a jerk. We're overwhelming, flooding, and just bogging down the resources on that victim or target. So one of the more common ones you'll see now is perhaps an ICMP or a ping flood. And we can certainly send other kinds of floods. One of the most common ones you might see is a SYN flood. SYN flood is another denial of service or DDoS attack, which will make that server or your victim unavailable to respond. It'll be just too busy. It'll be bogged down. It'll be hosed because something will be consuming all of the available server resources. We're going to cause that by sending packets with that SYN flag set. So you know TCP packets, right? TCP being the transmission control protocol, which ensures there is a connection in place by using the three-way handshake, right? The client on one side of the conversation will send to the server a packet with the SYN flag set to synchronize or start the conversation and begin requesting communication. The server over on the other end of the conversation will say and respond back with a SYN ACK packet or a packet sent with those flags set. Finally, the client, knowing that the server has responded, that someone actually answered the phone, it will respond once more with an ACK flag set on a packet, or the acknowledgement, okay, someone is listening and we can talk, we can have this conversation. Interesting thing though, on step 2 of that process, or in the middle of the three-way handshake communication, the server, while it sends that SYN ACK packet, it will wait to receive that ACK packet from the client so that it can begin having this conversation. So, the attack is simple. We just send a ton of SYN packets where we're just starting all these conversations. We're dialing the phone, but once someone answers, we don't care. We don't respond to them with an ACK packet. So they're overwhelmed, right? The phone keeps ringing. They're going to pick it up and they're going to want to talk to someone, but no one will be there. They're just not having this conversation, but they're still holding the phone and more are ringing. That will hog all the resources. That will cause that target victim to not be able to respond to other legitimate traffic because, okay, hey, they're busy, tied up with other stuff. All those resources are being utilized right now. Because this attack brings that server to the halfway point in the three-way handshake, right? They've started the communication but have not responded to the server's acknowledgement. That means that it's halfway communicated. That's why it's called that half-open attack. Kind of interesting. So let's take a look at the source code, right? Scapy, again, makes this super duper easy. We're performing this attack in, realistically, 2 lines of code. that could even be shortened to 1 because, hey, maybe we could abstract out that object that's not necessary for that SYN flood. We could just pass that to the function. So I'm creating the SYN flood object or variable, right? I send in a keyword argument for the destination. Again, just an IP address we'll use. We'll set an ID number for that packet and we'll specify the time to live. These values aren't extremely important for kind of just our discussion, but obviously that next layer certainly is. We create a TCP portion of this packet, and that sport, or S port is how you should read that, for our source port, that's just going to be a random ephemeral port that Scapy will help us generate with that rand short function there. That'll return something that make it look like, okay, we're coming from a different port every time. The D port, or the destination port, will be passed in as a list or a little Python array. We'll just send this over to port 80 HTTP. You could specify this to whatever you wanted to, maybe SSH or anything specifically. Specify a sequence number, specify an acknowledgement number. Again, for this example, those don't really matter all that much, but maybe they could in other scenarios. The window size, and the most important thing here, the flags that are set on this TCP packet. Obviously, I'm just passing in a string here with that capital S, and certainly enough, that stands for SYN, right? The SYN flag has been set on this packet. So we have created one packet that is just a SYN packet, the very, very first step in that TCP three-way handshake. The next line below, we're going to end up using that SR loop function that Scapy makes available to us. And that is going to send and receive packets in a loop. So we will repeatedly, over and over and over again, send this packet. The keyword arguments there, that inter or the interval, we'll send those at 0.3 of a second. We'll retry every 2 seconds if that kind of gets dropped. And we'll have a timeout of 4 seconds. Again, those are a little extraneous, but the point that we're getting across right now is that we are looping a SYN packet being sent over and over and over again. We are flooding that target victim server with this SYN flood attack. In the case of the line of code there, we have an answered and unanswered information that's being stored as a return value of that SR loop. That'll just return a tuple, okay, or a list of what packets actually had a response and what didn't. The point that I'm trying to get across is that just these 2 lines of code are putting together this attack. And it's super duper simple. All you've done is outlined the structure. You've orchestrated this packet, and now you can put it to work. You can weaponize it as a SYN flood. You might notice, though, in this example, with this setup right here, we're sending this SYN flood attack just with our attacker machine. One machine. So potentially, that endpoint or that target, the victim server, once it realizes, hey, I'm under attack, right? I'm in danger. If they kind of had the opportunity to look through some logs or could figure something out and determine, oh, I know the source of this attack, I can just block it off. Well, you're totally right. That's absolutely doable. For that reason, this kind of thing isn't often done just with one host, just with one attacking machine. So you bring in the conversation, okay, we're performing a denial of service attack, a DOS attack or a DOS attack. But if we had more machines in this pool, if we were attacking with multiple hosts, we could be performing a distributed denial of service attack, or that DDoS. That might make it a little bit harder to do, harder to track down, harder to trace. However, we could do even more. We could go one step beyond that when we say our source IP address, we don't want that to look like it's coming from us. We want to hide it. We want to mask it and obfuscate that just a little bit more. But you can tell with Scapy, we are crafting our packets at the granular level. What's to stop us from specifying just that information, just the bytes, the real information that we need within that header of the packet? We could say that our source IP address comes from a different IP address, comes from a different host. We can spoof our IP address simply by passing in the keyword argument. Just as you see the example there, we specify that DST keyword argument as an IP address string, we could just as easily specify SRC, or the source IP address, and make it look like we are coming from a different location. We can spoof our IP address super easily with Scapy. And we can use that as a segue into the next attack, DNS amplification attacks. A DNS amplification attack is a really interesting technique that abuses the regular functionality of DNS, or the domain name system, to again overwhelm, spam, and flood a target or victim machine. The way that this works is that the attacker actually sends a legitimate regular request to a DNS name server asking for as much information as they can. So their request is a regular kind of small, tiny packet just asking for information, and the domain name server will respond with as much information as possible, and that way you get a much larger packet in response. The trick here is that with this DNS amplification attack, the attacker sets their IP address, the source, back to the actual victim or the target server that they're aiming to overwhelm and choke. You can see this here in the source code, right? We're defining, again, another object or variable to keep track of our packet. We're defining an IP header, but interestingly enough, we supply that SRC keyword value, or the source IP address of the packet that we're going to be formulating. Note, this will act as our victim. This is the target machine that will have the domain name server send back that large request. You can see again our division symbol, or the / to add new layers, and we're adding a UDP packet portion, right? We'll set the D port, or the destination port, to 53, the default port for the domain name system or DNS servers. And what we're going to query from this DNS is anything we'd particularly like. Here, I'll just ask for anything regarding google.com or that domain. You could, of course, ask for any type or any resource record you'd like, an A record, a text record, a CNAME record. Generally, with this attack, you could expect to see the attacker request for any, as in return all of the resource records you could give me. We'll have that packet formulated, stored, and encapsulated in that DNS amp object and variable, and again, we will just send that packet along. The DNS server will respond accordingly. It will give all the information it can, but send it to that source IP address, not our actual attacker. That will flood and overwhelm, choke that target victim server. Obviously, you'd want to have more than one attack or one attacking machine doing this. You could perform this distributed denial of service, right? That DDoS, or send this request multiple times. But I think this attack is really cool and really interesting, right? If you put it in kind of layman's term or a normal human explanation, say you are at the drive-thru ordering some fast food to go, or whatever the case may be. Let's say you ask the person or the teller that's chatting with you and taking your order, I want one burger, or I want one drink, or whatever. Typically, that job of the teller will read back your order, right? So envision this scenario. You as the driver, right? You as the attacker, you say, I want everything on the menu. And then before they can read your order back to you, you drive away and let that next person go ahead and actually hear all that information. So while you just asked for a small tiny thing and a simple, hey, give me everything you've got, the next person or your target or your victim is going to be read and enumerated and receive all of the information. So maybe, I don't know, what a 1 scale for your packet could respond to a 10 in the response and what that teller will read out to that other person or that individual. Kind of cool. And obviously, another added benefit to this is that the attacker is performing this attack indirectly. They make this request out to an open and accessible DNS resolver, and it will respond and just send that information out to the actual target or victim themselves. The attacker doesn't really leave any fingerprints or a trace on the target. It's not reaching it directly. It is an indirect attack. You can see that here again with that syntax, but as always, Scapy is making this really, really simple and honestly really easy. Okay, now let's talk about our finale attack. I want to discuss BGP abuse. So BGP is the Border Gateway Protocol, and that is the standard routing protocol of the internet today. That means that it's actually telling your computers where these packets are going to go when you're working on the internet or at a large scale, the wide area